The last two problems, I really want to point to the last part of this section. 28. Now, even though those barely come up at the end, but that's coming up heavy toward the end of this chapter when we do the 3 triple integrals. You're going to come across those. Find the area of the region that lies inside of r equal 1 plus the cosine of theta and outside of the circle r equals 1 plus the sine of theta. If I would go ahead and just copy this previously, and here it is. So if I glance at this, and I want to know what this looks like, I know how to graph those quickly, I just don't know them by name. So this r goes up 1 unit, that's the vertical shift. The amplitude is 1 up, 1 down. At cosine starts at the top of the amplitude, runs down, back up, and this is 2 pi over 2 and 3 pi over 2. This graph starts at 2, decreases. By the time I hit pi over 2, I am at 1, decreases. By the time I hit pi over 2, I am at 1, then keeps on decreasing. By the time I hit pi, I am at 0. There's pi, there's 0. And we know this graph is symmetric with respect to the x-axis, so we know the graph looks like that. Versus this graph right here, r equal 1, this is simply that circle right there. So when the direction states, find the area that lie inside of the circle, outside, they're talking about this region. Inside of this cardio, outside of the circle. Well, this is how it works. You could write this a few different ways. Area is going to be, it's a double integral, and let's see how this works. So, I could say this runs from r dr d theta, and we're going to run this from 0 to pi over 2, and since I'm only taking half of it, I'm going to multiply that by 2, and r seems to run from the circle r equal 1 and terminate on 1 plus the cosine of theta. And that was it. That's pretty much how you do this problem. There's not much to it. Of course, graphing is a key, and pretty much if you can graph it, you're in big trouble. And the last problem I want to touch on is problem number 32. Again, I would have did a lot more, but this is all they have. But this is coming up toward the end of this chapter. We're going to come back and do this heavily using triple integrals, using spherical coordinates and cylindrical coordinates. So again, the graph is half of the problem. If I really look at this graph, and let's see how this plays. If I color code those, then I could kind of visualize that quickly. Graph is half of the problem, really. So if I take the first graph, r equal 1, we just graph that, a unit above and a unit below, and this graph starts at the amplitude down back to the starting point. There it is. If I really want to mimic that on this, at 0, I am at 2, here I am, pi over 2, 0, we just did this graph. So it looks something like this. And if I really look at the second graph, this also starts at 1, and it moves up 1 and down 1, except this is upside down. So we know this is wrapped around the negative x-axis. So this one starts at 0. By the time you hit pi over 2, keeps on increasing by the time you hit pi, and it's symmetric. when they say find the area of the region, let's see how this works. Common to both. Wouldn't this be common to both? Now these are symmetric. I'm going to assume they're not symmetric because that is going to happen later on. So I'm going to say area equal, and I'm going to start by finding the area of this top portion only and multiplying that by 2. That's where the 2 comes from. The double integral of r dr d theta plus, so again, I'm assuming they're not symmetric. If you're certain they're symmetric, you could just do one of those and multiply it by 4. But if I run this from theta equals 0 to theta equals pi over 2, I'll notice that I'm running from 0 to the blue curve, and the blue curve is 1 minus the cosine of theta. Now, again, assuming this is not symmetric, suppose that was a 2 or a 3. Now, I am going to run from pi over 2 to pi. So now I'm running from this all the way down. And do you see once I pass pi over 2, I am running still from 0, but I'm running to the red? And there it is. So if you can get the graph, this is pretty simple. And that's going to be the same case when we get to 3D. The homework on this section. This is section 15.4 on page 919. And you're going to do numbers 1 through 21. You're going to set up the odds, and you're going to solve every other odd. You're going to skip number 5, and you're going to do number 29 and 31. And that would be it for this section. So in our next class meeting, we're going to discuss this, and I'll talk more about what that means.